This is YouTube for Chapter 4, Part 2. We will continue to talk about the rest of our control structures, some more examples with the break and continue statements, and logical operators, and the assignment operator confusion right here, the equal versus the equal, where equal is assignment. Okay, so first let's talk more. Okay, so let's first look at the use of another example of using the break statement. So I have a little piece of code. It's a loop that iterates 10 times. It prints each value of the control variable. So it will print out my loop iterator s, the value of it. But I have here embedded within the loop an if statement. If s is 5, it's pretty much if the value of s is 5, break. And what that does is it causes my loop structure, my for structure, to be exited and go to this piece of code down below that just prints the value of s. So when when some certain condition occurs within the loop, then the break statement will cause an immediate exit from the control structure. And that's if it's a while or a do while or a for loop or a switch structure, which we use the break in the switch structure. So it's also true there. So if I run this little piece of code, there it is. And you can see it prints out 1, 2, 3, 4. It makes it successfully through the loop 4 iterations, but then it encounters s equals 5 and it breaks out of the loop. We can also, so it breaks out of the loop and it doesn't do anything more with the loop. The continue statement behaves a little bit differently. When the condition occurs, the continue. Yep, that's not quite right. Let me fix that. All fixed. That's the joys of copy-paste stuff. Okay, so this time you're going to go through the loop it's set up to go through the loop 10 times, but when the condition occurs, that is when s is 5, the continue statement skips the remaining part of that particular loop. In this case, it will skip the next part of the next statement in the loop, which is a printf statement, and go back up and start the next iteration of the loop. So in this case, it will skip, it's printing out the value of s, but it will skip s is equal to 5 because the continue statement says skip the remaining part of this loop and start the next iteration. Okay, next we're going to look at our logical operators, but before we look at our logical operators, recall that we have so far been dealing with rational operators, less than or equal to, greater than or equal to, and this test is equal to or is not equal to. Just a bit of comments to make sure we don't have confusion. This equal sign is a test. It's something that evaluates to true or false. Always, is A equal B? So is A equal to B? That should not be confused with the single equal sign, which is the assignment operator. And here's my little snippet of code. Int x equals 5. X is the assignment operator, i.e. x is assigned the value of 5. So don't confuse the rational operator, which will evaluate to true or false, with the assignment operator, which is giving something a value, giving a variable a value. So now our logic operators, they're A, B, they are ands, ors, and nots. They are just like Boolean algebra terms, and, ors, and nots. Matter of fact, that's what we are doing. We are doing Boolean algebra operations. And so this is a truth table I have shown right here in the gray. So if I'm looking at the AND operator, which is represented by, you type it as 2 ampersands. If A is false condition and B is false condition, then A and B is false. And you will see that the only time A and B will evaluate to true is if both A is true and B is true. And I'm going to show you some examples. And then there's the logical OR, and it's written with this 2 vertical hashes. They aren't slanted hash marks, they are vertical. On my keyboard, it's right below the backspace. It's a shift backspace that gives me the vertical hash marks. Or vertical bars, not hash. So this one is if A is true or B is true, then I will get a true statement. So let me show by example. And then there's not. We're already familiar of the not by our not equal to tests. So here's two examples from the textbook using them with some kind of variables that kind of make English language sense. So if gender equals a 1 and age is greater than 65, then you're going to update a counter that's counting the number of senior females, apparently. The order this statement, this if test is evaluated, it's going to evaluate is gender equal to 1 and is age greater than 65 before it evaluates the AND logical operator. And that's as a result of our precedence, which I'm going to go back and review you the precedence in just a moment. This is an example of an OR statement. If the semester average is greater than or equal to 90, or final exam is greater than or equal to 90, then you give the student an A. So it's an OR statement. One statement or the other must be true, or both can be true, and you'll give the student an A. So a little bit about the precedence, the order that things are performed in your if statement. I took this was on your C reference card. Remember, I pointed that out in the last YouTube that on Laulima, I've uploaded this C reference card. Whoops, just make it so you can see it. Yes, the C reference card right here. C reference card for NCC standards. And there is a section about operators with precedence, and so I pasted it here bigger for you to see. You can see things like increment and decrement and logical not. They're performed first in any test, then the multiplication, then the addition, subtraction, and as we move down, the comparisons, our rational operators, are performed before the test for is equal to, or before the logical and or the logical or logical operators. So let's do by example here. I think example will make that clear. I have a piece of code right here. I've declared 4 variables. They're doubles, A, B, C, and D. And then I have a test. If A is less than B or A is less than C, print true. Otherwise, you're going to print false. So let's look at how you attack this problem. Let me get my pen going here. Good enough. The way you attack it is you know that the precedence is to do these comparisons before you do the logical operation. So it's like you have parentheses here, here, and here, and here. So it's saying that we perform those things first. So this is the way you attack it. You say, is A less than B? There's A, there's B. No, that's a false. And then is A less than C? A is 5.5, C is 10. This is true. So now I have false or true. So it's an OR statement. If any one of these things is true, it'll evaluate to true. So in this case, the test would print true. Let's look at a more complicated one. This one's a bit challenging. I do it just for illustration purposes. So you say, oh my gosh, this is an awful looking test. If you would have to evaluate this for real, you'd have to, well, if you were to put this in your code, I would actually want you to put in the optional parentheses just to help make reading this a little bit more clear. So because it's a tough one to get through. So, but first thing we know is that these comparisons are going to be evaluated first. So we have to find them all. So is A greater than B? That's a true. A not equal to B. Let's see, check my precedence real quick. So not equal, occurs before our logical operations. So okay, so this is this one is a logical operation, but this has to occur before. So A not equal to B, that is a true statement. That's for this right here. There's a logical operation. So C greater than D, C greater than D, that's a false for here. Another test is C equal to 11. That's a false. And then is C greater than D? That's a false. Okay. All right. Now what? What's next? Next is you have to look at which logical operator is performed first. So I check my precedence chart and I see that AND has precedence over OR. Logical AND has precedence over logical OR. So that's sort of like that. I'm going to switch colors just to make it more evident. That's like, oh, there's an AND statement. This AND has to be evaluated before that OR statement, and this AND has to be evaluated before this OR statement. So now I've put some brackets in to help make it clearer, and I have true and true. Oops, is A greater than B? A is greater than B. Yes, A is greater than B. True and true evaluates to a true. Correct. False and false evaluates to a false. And so now I'm left at this point with a true or a, now it goes left to right because all I have left is OR statements, or a false or a false. And what does true or false evaluate to? Well, it's an OR statement, so you only need to have one of the things be true. It's going left to right at this point, so I can say true or false evaluates to a true, and I'm OR'd that with a false, and true or false evaluates to a true. So in the end, this entire statement would evaluate to a true. Yes, correct. So, so this chapter was also supposed to cover the do-while control statement. At least they said so in the beginning in the outline, but they never once gave you an example of a do-while structure. So I will give you an example of a do-while structure. So this is the general form of it. You do have to initialize up above. It is a post-test loop structure. So the test condition for continuing the loop is at the end. So you would have to initialize your variable, do whatever statements, and then while the condition is still true, you'll go back and repeat the statements. So I'll give you an example. Here's my example. So I initialized x equals 5, and I'm just going to increment x and then print the value of x. And then, so it's going to go through the loop the first time, and as it's going through the first time, it automatically incremented x, right? It started, x was 5 before it went into the loop, but the first time it goes through the loop, it already incremented it to x equals 6. And you can see, because here's the output, it printed the value of 6. And it says while x is less than or equal to 10, so 6 is less than or equal to 10, it goes back and it repeats the process. But eventually I get to x is 10. Is 10 less than or equal to 10? Yes, so it's going to go back and do the loop again and increment the loop, increment it, and so you actually end up printing the value of 11. So this is what a do-while loop is, and I also saw in your textbook that there was no flowchart associated with it, so I'm going to go ahead and draw one, or a piece of one. Here is the body of the loop, whatever loop actions have to occur. In this case, it's the x is incremented and the print function occurs. And then I go and do the test. If the test evaluates to true, I go back here and repeat the actions. I go back and do the actions again. So if the test is false, I exit the loop. So that would be what its flowchart looks like. So there's only a little bit more to cover in this chapter, and then I'll look at some My Programming Lab. Actually, I was just flipping through the book again, and there was a section on the do-while so I was wrong. There was a very short section on the do-while thing. They do draw their flowchart a little bit different. I think this is the way I learned how to draw it, but oops. You can also, the way they draw it is they make it come back in ahead. So that's okay. So yes, there was a do-while example. It was very short. It's actually similar to mine. I did show what some of the features are by showing how I got 6 to 11. Maybe when I wanted, maybe when I was doing this problem, a person doing this problem, you have to be careful. If you wanted 5 through 10, you weren't going to get it. So my example was kind of intentionally that way. Don't know how I missed that when I read through it, but I did. But nevertheless, we've covered it. So let's look at the rest of this chapter. The almost last section of your textbook is about, the section is called a structured programming summary, but it's really talking a little bit more about flowcharts. Our programs so far are small enough that it's not a big deal, but it could become a big deal, and flowcharts are very useful. So one thing to always keep in mind is you start with the highest level or simplest flowchart first. Like maybe it's a simple like the simplest thing that you could possibly imagine, what your inputs are, what your outputs are, some block in between that maybe has a decision structure in it of some kind, and make it simple. So sequence is just executing one line of code after another in sequence. It's a sequential programming thing. C is mostly a sequential programming language. Even though you can have some decisions made, you are still executing C from kind of a start to finish progression, as compared to C++ or C#, which are object-oriented languages that we'll talk about some at the end of this semester. This is a summary of our selection structures. The flowcharts are there for each one and what their structure looks like. And then we have a summary of our looping structures, which is while, do while, and the for statement. So those are loops. Those are selection structures, if else, and switch. Loops are while, do while, and for statements. So flowcharts, I said, have to start with the most simplest ones first. So on a high level, how simple can you make? You enter the program, this is a start, you do stuff, this is the exit. That is the very simplest form. But as it grows, things will become progressively more detailed. Like you have a start, do a process, end. But now you have a start, do first process, do second process, end. Because really more than one thing probably happens in the code. And so you can get more and more detailed and build up these sequence components with, as your program grows and you get more and more detailed flowchart. Nothing wrong with that. So now what else can you do is you can also take something that's supposed to happen, some action that's supposed to happen in your flowchart, and maybe there's a decision that has to be made. So you can replace this action block with, oh, really, there is a decision that has to happen in the program, and you can replace the flowchart with that. You can even nest it even further. This thing might have, and you can see that you can nest loops, you can nest tests, you can do all kinds of things in the flowcharting and get the flowcharting to be a more and more complex flowchart. Using this designing, this is the top-down design method again, starting from the simplest and then breaking it into different sections and components. This is drawing the picture of what the code has to do with a flowchart is very useful for understanding what has to happen in your code before you ever actually type in the correct syntax and make it happen in a coding environment. This is why I don't like e-texts. They're a little bit slow to load versus my paper book, which I can flip the pages. This kind of a structure where one action overlaps another is not allowed. You have to keep things stacked and in sequence, and you are allowed to nest things. If you attempt to do something like this, you're going to get results that you don't want, even if the program actually even works. And it says that if you're not sure of your flow chart, you can try to reverse and put things back together again. So if your program is truly structured, you can go from simple to complex and complex back to simple very easily. So you really, to do any kind of program whatsoever, these two guys named Bohm and Jacopini showed that you need sequence structures, selection structures, and iteration, and you can accomplish anything in a program that a program needs to accomplish. In my programming lab, you'll have a bunch of problems out of Chapter 4. I took a bunch of them out so you don't see them anymore because otherwise you're going to spend so many hours, and I think you get the point quicker than that. So on my programming lab, one of the things I did notice when I went through all the problems is sometimes you have to not read too much into the problem. For example, this problem, given an int variable I that has already been, oh, not that one, that's not the one that I wanted. There was one that was kind of silly the way they wrote it. Oh, logical operators, this one. Write an expression that evaluates to true if and only if the value of an integer variable identified by worked overtime is true. Now remember, every time something is going to evaluate to a true or false, it's going to evaluate to a 1 just by nature of it being. So I could say, I could do a test, worked overtime equal 1, but it's simpler than that. So I'm actually going to show you the solution. So if you've watched the YouTube, you will definitely know this answer. So the solution is just write the word worked overtime, and the value of that is 1 if and only if that is true. So and then there are a few other possible answers, like work overtime not equal to 0. That's also a possibility. So don't read too much into that problem. So let's look at now the next one. Some of these were kind of funny. Okay. Write an expression that evaluates to true if and only if temperature is greater than 90 and, now read the word there, and humidity is less than 10. So you can see that there's going to be a logical and operation in that. But again, don't embed it in too much of a structure. Again, I'm showing you the solution. Temperature greater than 90 and humidity less than 10. So be careful also when you read these questions that it says greater than, not greater than or equal to, and less than, not less than or equal to. So I've seen a few people mess up with that. And since it's not embedded in any kind of an if statement or anything like that, there's no parentheses, there's no semicolons, etc. So it's simplified in many respects. The only other thing I'm going to point out is I am going to attempt, there were 3 programming problems in this chapter. I'm giving you the first one here. So it's writing a sum of integers, and you're getting the integers from the keyboard, from the standard I/O. So you have an interactive portion of your session right here that lets you try out what the output should exactly look like. These dots mean that there's a space there. And when you put your solution in, it's to write a complete solution. So don't forget to include standard I/O. You do not have to, in this case, put the preamble information that I require of you if you are submitting a complete program on Laulima. Here you have to put the include standard IO.h file header, and then write the complete program. So this is we'll see how it goes to submit complete programs on Laulima. I mean, not on Laulima, on my programming lab. We'll see how flexible that is. And then you do have one program also to submit as an executable and source code on Laulima, and that will come up with a different document shortly.